Okay, so let's get started, guys. We have Structure Analysis 1, and this is actually in this course we'll be studying basics of structural engineering. Normally, there is a difference between structure analysis and mechanics of solid. Can you tell me what did you do in the mechanics of solid, first of all? Like, what was mechanics of solid about? You have done, I presume, MOS 1. Yes. Yeah, but what was the main thing you did in mechanics of solid? Something which is common. I mean, like, you kept on finding that out. Yeah. Well, you were trying to find out your stresses. Okay, stresses and strains. That was your main aim. And beside that, you had deformations. So those were the things which you were working out. In structure analysis, it's actually the structure analysis and mechanics of solid, they both are related to each other. Mechanics of solid is actually telling you the stresses and strains in a structure. But for stresses and strains, you need to know about the forces, the applied load, how these loads go into the support, okay? So the flow of loads, yeah, that is actually, that is captured by structure analysis. So in other words, for stresses, what is a stress? Stress is force time area, okay? But, so how do you normally find out your forces? Your forces, that is structure analysis. Structure analysis tells you what forces you have in the structure. Now, what is a structure? A structure is an element which is subjected to some type of loading. That element must be supported somewhere. Okay? So any element you can see, it can be a one element or it can be a combination of elements. Many elements which are joined to each other. Okay, so this is your structure. Now, and on that element, you have a load applied. Okay, and this load then goes to the support. That is, so your objective in this class would be to find out what reactions you have. You would know the load, applied load. You would be required to find out the reactions, and based on the reactions, you would be asked to draw shear force and bending moment diagrams. Okay? So that, and after that, you would be asked to find out deflections. Okay? So this is the main aim. So actually this course can be divided into three parts. The first part is your structure analysis, simple structure analysis, applied load, find out the reactions, okay, and use the available equations. Now we will come to it, where do we get the equations from, but that is the first part, which is analysis of structures. By analysis we mean finding out the reactions, okay, and drawing shear force and bending moment diagrams, okay, that is the analysis part. So then after that, the second part of the course is about deflections. So you would use, after finding out, after carrying out structure analysis, then you would be able to find the deflection. Now what do we mean by deflection? How the structure deforms. When you apply a load on something, okay, it will deform, isn't it? Yeah, you push someone, so he reacts, and I mean, like, you know, that behavior after applying the load, that is sort of deformation. So you have to find out what is the profile of the structure after application of the load. Before application of the load, the structure is straight. After applying the load, it will take some shape. You have to determine what that shape is. So that is deflection. So that is the second part of the course. Okay? The third and the final part is influence line. How would the structure behave if you have a moving load? Now, in the first two parts, your load is static. Okay? So, by static we mean you have load applied and that load is not changing its position with respect to time. Yeah? That is static load. In the influence line, which is the third part of this course, that involves a moving load. Now, for example, I've got this structure. This is one structure, a structure which is supported, okay? And I am moving, yeah? I'm moving. So, initially I was static over here. It will have one sort of behavior. When I'm moving, yeah? When I'm moving, then that behavior will change. So, you will be required to find out bending moments and shear forces in a beam, in the third part, when the load is moving. You understand my point? Yes. So we have three parts. The whole course is divided into three parts. The first part, structural analysis, okay, which involves finding out reactions and shear force bending moment drawing shear force bending moment diagrams. Okay, that's the first part. The second part is your deflections. Okay, what would be the profile of the structure after application of the load? And the third one would be your behavior of structure, or finding out shear force bending moment, or in other words, analyzing the structure when you have a moving load. Okay, so these are the three parts which we will be doing. But before that, before starting any course related to structure analysis, it is important that you get the sense of appreciation of a structure. Okay, that is very important. Now, what do I mean by appreciation? Okay, by appreciation, we mean that if you are applying some load on a structure, you must realize what weight that is. You must be able to compare it to something which you know. Okay, that is called appreciation. Like, for example, I apply 100 kg load on a structure. So I must be able to appreciate how much 100 kg is. Okay, so what do I mean by how much 100 kg is? So, for example, how can I, so what, like human beings, they always have some reference point with which you compare anything. That is important, because, like, you know, if you don't develop your reference point in structure analysis, then everything which you do comes out to be like, you know, just cramming, nothing else. Okay, so reference point is important. Like, for example, if I tell you that a structure is 12 feet long, a beam, do you understand what a beam is? Yes. A horizontal member which is supported at different points. Okay, so it's a simple horizontal member. That beam, if I give you a length, you should be able to appreciate it with your reference point. Okay, now how do you develop that reference point? Okay, like, you must know something which is approximately of that length. Okay, you must develop an image of that in your mind. Now, how do we do that? Like, for example, the best thing with which you can compare your structure is, like, for example, a room. Okay, now this is our room, and what are its dimensions? Okay, we don't know what the dimensions are, but we can determine what the dimensions are, and then let this room be a reference point, and then we can compare whatever structure I give you, I throw on you, you compare it. Okay, because if you develop the image of this room and you know approximate dimension of this room, then you can always come back to that structure and you can appreciate whether that's very long, whether that's very short, and similarly about the weight, what load is applied on it. Okay, that load you should be able to appreciate also. Like, how much big is the weight? Okay, so we have to, in other words, develop a reference point. Okay, so let us try to develop first of all the reference point. So we start from this room. Okay, what do you think is the height of this room? What would be the height of this room? What? How do you compare 12 feet? How do you get 12 feet in your mind? The first thing which we can see is our height, isn't it? How high this would be as compared to my height. Okay, so for example, this is 12 feet, yeah? You say that this is 12 feet? Yes, sir. Okay, so yes, I agree. Approximately, I mean average, it would be twice of average person height, approximately, yeah? So that's how we can say that this is approximately, 12 feet, yeah? So if this height is 12 feet, now we have got one reference point. which is 12 feet, okay? So you develop, you set out that image in your mind that this is 12 feet. Now if this is 12 feet, how much is the length? How much is this length then?
24. 30 feet. 20.
How many times should I add this height to get the length, to get this length?
30 feet.
Yeah, approximately, yeah,
30.
Yeah, 2.5 would be a bit too much, but it would be slightly more than 2. 2.2, 2.3. Do you agree?
Yes.
Like for example, this height, this width, we are talking about this dimension, okay, the horizontal dimension. So this one would be, but this is almost the same, isn't it?
Yes.
So that means, yeah. Is it exactly the same? Is the width and the length the same? Do you think? I think so. This is a bit longer on this side, and it is a bit shorter on that side, isn't it?
Yes, sir.
Okay. So let us say, okay. So if we have established that this is 12 feet, okay. Normally 12 feet or 3.2 meter is average height of the of a room, okay. And then this one would be say 2.2, twice of this height, so 24, 26, 26-ish. And how much would be this? Say make it 30 approximately. Because this is slightly more. This is all approximation, but it's a reasonable approximation. So if you as a structure engineer, like look, someone will ask you to come visit and carry out some inspection. Okay? So how do you carry out some inspection? You look for the reference point. Okay? That where is the reference point? Normally the best reference point is either height or either it can be like, you know, if the room is divided into, if you have tiles on the roof, yeah, so then I mean you just measure one tile and then you add those number of tiles and you get almost a very good approximation of that. So that is developing your appreciation for something, okay, sense of appreciation. So that's how I mean you get to find like how much is the height, how much is the length, how much is the width. So tomorrow if someone is telling you that okay, I want to have a room which is say 100 feet long, so at one click something will come in your mind that yes, the room where I'm studying, okay, our classroom is round about how much? 30 feet. So he wants it how much longer? Almost twice of that. Thrice of that, yeah, almost thrice of that. So that